Dear students, welcome to Atoms to Infinity. Today we are going to do a paper 2 worksheet which covers the extended syllabus for general properties of waves. I will try to explain each and every MCQs in the greater depth so that you can really understand if there is a similar question like this. However, if you don't understand a question, if you don't understand the explanation, do tell me in the comments and I'll really answer. Right, without further ado, let's start the first question. Radio waves are received at a house. Okay, here we have a house, here's a hill, and here all of these radio waves, incoming radio waves. Now you see there is a bit of a distraction, a barrier, and all of these waves are curving around this barrier. So an effect where all the waves they curve around a barrier, it is called diffraction. So all the radio waves are getting diffracted. Option A was correct. Now in question number 2, a water wave in a shallow tank passes through a gap in the barrier. Right, what happens to the speed and what happens to the wavelength of the wave? Right, if we now in this question, the question is not really mentioning if this is deep water here or if it is shallow water here. So medium is same, so I can write like M1 and M1, like there are same mediums. So of course it will bend, of course, but there will be no effect on speed and wavelength. So remains constant. Option D is correct. Now you need to remember the speed of the wave or wavelength would only be decreased or increased if we are changing the medium. For example, if the wave is going from deep water to shallow water or vice versa. Right, in question number 3, we need to tell them what is the unit of a wavelength. Well, the unit of a wavelength is meter, and for your reference, the wavelength in the case of a transverse wave, it's basically the distance between two adjacent crests or two adjacent troughs, like this. So this is a wavelength. Right, which list contain only transverse wave. Now let's see. Infrared waves, light wave, sound wave. Sound wave is a longitudinal wave. Infrared, light, ultraviolet. Yes, this list contains all the transverse wave, because if you look at it in option C and D we have sound waves, so that means this option is incorrect. Okay, now in question number 5, the diagram shows a wave. It's a transverse wave which labeled a distance is a wavelength. Like I just told you, the wavelength is basically the distance between either two crests or two troughs. Right, here we have option D. So D is basically telling us the wavelength of a wave. Right, in question number 6, here we have fast, you can say deep water, here we have shallow water, and the wave speed is shown that the wave is very fast in deep water and it is slow in the shallow. Right, we need to choose what will be the direction of all the waves. Now if you remember, I told you that last time in my last video on sound, that when sound waves or any wave goes from dense to rare medium, a rare medium is less dense medium, so it bends away from the normal, bends away. So here there is no change in the direction. Of course this is incorrect. Now these waves are going towards normal. If I draw the normal here like this, this could be my normal, okay, incident wave, and that is normal. So that wave is traveling towards normal. That is incorrect. That is incorrect as well, because this it basically showing us that the wavelength has decreased, which is certainly wrong. Now here in option C, we are seeing that all the waves are going away from the normal or bending away. So option C is correct. Right, on question number 7, we need to tell them what is the number of wave fronts per second that passed a fixed point. Well, if we take this fixed point, and these are the wave fronts which are passing through this point, so we do remember that after 1 second this will pass, and after the second this will pass, which is basically the wavelength. That is basically the difference between two wave fronts, because we only observe wave fronts. Right, here we have a cupboard that is placed in front of a heater. Now air can move through the gap under the cupboard. Here we have a cupboard, here we have a heater. Now if you remember, this heater will release heat. Now one thing that you need to remember about heat, that heat always travels from hot body to cold body. So imagine this is the cold region, here the temperature is very low, and this is hot region or warm region where the temperature is really high. So all the molecules will be moving from here to this side, like their motion will be like this. So in all of these options, option C will be correct, because air temperature will rise, air will be warm, and all the heat will be traveling away from the heater. So like that is how all the molecules will be like traveling from hot to cold. So option C is correct. Alright, now this diagram shows a water wave in a ripple tank. Which line represents a wavefront? Well, you know, if you're watching this wave from above, like if this is your eye, so you will be watching only B. So B is basically the wavelength which is shown to you. Now in question number 10, the diagram shows a side view of a water wave at a particular time. Now you know time has been stopped. The diagram is full size. Okay, now the size is like, the scale is accurate. Which statement about the wave is correct? The wavelength is longitudinal. No, this is a transverse wave. Longitudinal waves travel in the form of a compression and rarefaction. So this is compression and this is a rarefaction. Right, in option B, the wave is longitudinal. Certainly not. The wave is transverse and the frequency can be calculated from the diagram. No, we can't really measure the frequency here because we don't know where it was 1 second. If you remember the definition of frequency, those are number of waves per second. Since we don't know where the 1 second is, so we can't really calculate frequency. However, the wave is transverse and wavelength can be measured from the diagram. This option is correct. Because if you see, this diagram has a full scale size. So if you have a scale, you can basically measure the distance, which is the wavelength. Or you can measure this distance alternatively to find the wavelength of a wave. Right, in question number 11, we are shown with a diagram. All of these waves are directing or heading toward this barrier. Now after crossing this barrier, they will spread and they will approach this point P. I've told you that in question number 1 that when waves, water waves or any waves, when they curve around a barrier, this option A is correct. Diffraction, this is the process that is going to happen. Right, this diagram shows a water wave. Here the maximum displacement in the y-axis, this is y-axis if you remember, and this is x-axis. So the maximum displacement in the y direction, that is displacement, or you can say that is a maximum displacement or amplitude. So amplitude here is 2 meters, and this is like, you know, the wavelength is basically the length between 2 crests. Now this is basically the distance between 2 crests. So this is wave, all we have to do is like we have to divide 4 with 2 and that would give us 2 meters. So it is basically 2 meters here and 2 meters here. That means option C is correct. Let's go to the next question. Here we are shown with the diagram. There are some waves. Now students, do remember the shape of these circular waves which are traveling from S to S1. We need to tell them how these waves, circular wave fronts, will look like from the perspective of S1. Right, from the perspective of S1, these circular waves would look like option D, because the shape would match. Right, let's see question number 14. Which row correctly defines a type of a wave and gives a correct example? Longitudinal, parallel to the direction of wave travels, yeah. Radio waves, no, they're not longitudinal, they're transverse. Longitudinal, perpendicular, no, they are not perpendicular, they are parallel. Option C, which is a transverse wave, parallel to the direction of wave travel. And light waves, yes, light waves, they are parallel waves. You can say they are a transverse wave, and in them the molecular vibration is parallel to the wave. Alright, now there is a water wave that moves quickly in deep water and it will move slowly in shallow water. And if you remember that speed and wavelength of a wave have a direct relation. So if the wave speed is decreasing, the wavelength would decrease as well. Nothing will happen to the frequency, because frequency does not depend upon the medium. It would always depend upon the source. Since source is not changing, so frequency does not change and wavelength would decrease, because a wave is traveling from deep region to shallow region. Right, students, in question number 16, there is a transverse wave that is moving along a rope. The diagram shows the position of the rope at one particular time. Now we need to label 2 points which are 1 wavelength apart. Now if you remember, for a transverse wave, we can basically divide it into 4 parts. Alright, now for example, this is the first part, this is second, this is third, and this is fourth. It's like from 0 to 90 degrees, then 90 degrees to 180 degrees, 180 to 270, and 270 to 360 degrees, right? So there are 4 parts in it. It's like the 4 quadrants of a circle like this. So here we have like the first part. This can be our second, this can be our third, this can be fourth. So if we see that there is no point between W and whatever point here it is between Y and Z, so we should not take it from here. Let me erase it. We'll take the new points. For example, let's start calculating from X. So this is our first part, this is second, this is third, and this is fourth. So X and Z are basically one wavelength apart. So option C would be correct. Now let's go to the question number 17. I believe we have already done this. This is a barrier. These are incoming water waves which are traveling in the form of a wave front, and they're about to cross a harbor wall, and they will reach the boat. Now we want to make them stop reaching the boat. So first of all, we would name the process. The name of the process is diffraction, and if we decrease the length of this barrier, so waves will not be able to approach this boat at whatever point that is. So option B is correct. Name of the effect is diffraction. Change to the gap, yeah, we would have to make the gap slightly smaller so that waves, they never reach the boat. Now this is the same question. A small boat in a harbor is protected from waves on the sea by the harbor walls. These are harbor walls. They're acting like a barrier. So all of these sea waves will try to cross it and will bend or spread around the narrow edges. Now this effect is, of course, diffraction. We already know that. This is the same question. I'm just gonna, mark the answer. Now let's go to the question number 20. Which list shows electromagnetic waves in order of increasing frequency? Now, if you remember the electromagnetic spectrum, so we knew that visible light has less frequency as compared to X-rays, and X-rays have the gamma less frequency as compared to gamma rays. So this is the correct order. I mean, of course, visible light and there can't be gamma rays between X-rays and visible light. If you remember, then electromagnetic spectrum goes for gamma rays to radio waves, and it is basically with the order of decreasing frequency. So you need to revise it or watch its picture from internet. You will realize, or from your book. It's basically given on page 160 from IGCSE Physics. Let's see question number 21. The diagram shows 4 waves drawn to the same scale. Now P, Q, R, S are the 4 waves. They have the same scale. We can see their amplitude drawn here. We can see their waveforms. We need to choose which statement is correct. What seems to be the problem in this one? Let's see. The amplitude of wave P is same as the amplitude of wave R. Yeah, the amplitude is 1 here. I mean, if we say this is 1 and this is 1. Okay, now this option is correct. Let's see why all the others are not correct. The amplitude of wave S is double the amplitude of wave Q. Now Q and S, they have same amplitude, it's not double. So both have the amplitude of 2 meters or whatever the unit there is that you like to take, or the number. The wavelength of the wave Q is double the wavelength of wave P, right? P and Q. Let's see the wavelength. Now the question is talking about wavelength, and wavelength is not even given in the case of P and Q, because wavelength is only given in the case of R and S. If you remember, do scroll back the video, you'll see that what's a wavelength. So both the option involving the wavelength will be incorrect, and this B is also incorrect. So that's why I just said that part A is correct. Now, which waves are longitudinal? We do know that light waves are transverse, microwaves are transverse, water waves are transverse, so the sound waves are longitudinal. So option D is correct. Now this is the same question. I'm just gonna mark A. I remember the answer now. Right here at point X, somebody throws a stone, and this is like water. So we would have to see that which point is from the longest distance, like where is the longest distance, like x to b is longer, x to a is longer, or x to d is longer. We need to tell that, or x to c. Now, imagine this, that whatever the deepest region is, the velocity of the wave or the wavelength of the wave will increase. So of course, the further away this point is, the deeper is going to be. So option C is correct in this part. If you see, waves travel more quickly on the surface of water when water is deep. So a stone is dropped at point X into the pool, varying depth. The diagram shows the first wavefront. So yeah, you need to choose the region that is likely to be the deepest. So the C is going to be this one. Right, visible light and I don't know which rays, gamma rays are both waves. How may they correctly be described? Well, visible light is a transverse wave and gamma rays, they are transverse too. So option D is correct. Now here we have the same question. The diagram represents a wave. This is a wave. 2 points are drawn, x and y. How many wavelengths are there between x and y? If you remember, then we actually see this in the form of points. For example, this is the first region. This is second. This is third. This is fourth. And this is fifth. And this is sixth. So of course, the wave, for example, we would have to see this, how many waves are there. These are the regions. So at point 4, we have our first wave. Like this is first wave, and this is the another, you can say, half of a wave. So let's see, 1 and 1.5. So we have one full wave and we have a half wave. So of course, option C is correct. Now in question number 27, the diagram shows the surface of water in a ripple tank. A wave is traveling in the direction of the arrow towards the gap in the barrier. So medium is not changed. You see in question number 27, the question is not telling you if the wave is traveling from deep region to shallow region or from shallow region to deep region. So what happens to the wave? It passes through the gap. Okay, we would have to name the effect, which is diffraction. And what happens to the shape of the wavefront after passing through? Alright, so this process is called diffraction, and wavefronts will be curved. Let me show you how. Now that is how all the wavefronts are going to be curved. Question number 28. Which row shows an example of a transverse wave, an example of a longitudinal wave? Well, longitudinal wave is going to be sound. Okay, because radio waves, water waves, light waves, these are not longitudinal, so option B is correct. Radio waves are transverse and sound waves are longitudinal. So a boy throws a small stone into a pond. Waves spread out from where the stone hits the water and travels to the side of the pond. The boy notices 8 waves reach the side of the pond in 5 seconds. Now we need to calculate the frequency. So there are 8 waves in 5 seconds, and we need to know what is the time taken for first wave, only one single wave. Okay, so all the number of waves in a second. So let's see how many waves passed through in 1 second. We would have to divide them both. So that option is basically 1 point, let's just divide this. 1.6. 1.6 is the option. You can calculate this in your calculator. I didn't use it, so you can. I hope that is the answer. Now, what is the unit of wavelength? We already know this. This is meters. Wavelength is basically the length, so we have to take it in the units of meters. Which row correctly describes light waves and radio waves? Both are transverse. Let's go for the option D. Okay, now this is the same question that we have done. The option B is correct. The process is going to be the diffraction, and we would have to make the gap slightly smaller so that waves never reach the boat. Now, nature of the, we have already done this, I believe. Oh no, we haven't. So light waves, they are transverse, sound waves are longitudinal, and X-rays, they are transverse too. So we would find the option, which is option C. Light waves are transverse, sound waves are longitudinal, and X-rays are transverse. The diagram shows plain water waves passing through a narrow gap in a barrier. So the name of the effect is diffraction. As you can see, all the waves are curving around this small barrier. Now, water waves can be used to show reflection, refraction, and diffraction. For each of these, which row shows whether or not speed of the wave changes, water wave changes. Right, when it comes to speed, reflection and diffraction does not change the speed. Okay, they have no effect on the speed or the wavelength. But when we talk about refraction, refraction always changes the speed, direction, as well as it changes the wavelength. So of course which option is correct? Now B1 is correct. Reflection, no. Refraction, yes. Diffraction, no. As you can see the question, we were like discussing which process changes the speed or wavelength. Right, there's a vertical stick that is like dipped up and down in water at point P, and all of these circular waveforms has been created. Now, which statement is correct? Distance x is the amplitude? No, distance x is a wavelength. As you know, the distance between two wave fronts, or two crusts, or two troughs, or two compressions, or two rarefactions, the condition is that they have to be adjacent, that is wavelength. Now, distance y is the wavelength of the wave? No, this is not the wavelength. Each circle represents a wavefront, that is correct, because each circle is an independent wavefront. Which of these waves is longitudinal? So sound is a longitudinal wave. Let's go to the question number 38. Sound waves of frequency 2 kilohertz through a substance at a speed of 800 meters. So you would have to tell me the wavelength. You can use the formula V equals to F lambda. So it's going to be 800 divided by 2000. So of course, 0.40 is going to be the option, because if you cancel out these two, and you would have to like take a decimal point, and then you would have to add a 10, so it's going to be 0.40. You have to be very quick in maths in order to like finish this paper on time, so you need to use these small tricks and tips, etc., to verify your answer. Right, the frequency of a wave is doubled, the speed of the wave does not change, so it is constant. What happens to the wavelength of the wave? Now let's see. Speed or velocity is equals to frequency into wavelength. Now this is constant now, so we can take it 1. So that would be 1 over wavelength equals to frequency. So if the frequency of a wave is doubled, then wavelength would be half. Let's see how. 1 over 2 lambda. Because this 2 will be divided with this lambda, will be multiplied with this lambda, or divided with this 1. So it halves. That is option D is correct. Now in question number 40, a water wave passes into a region where wave travels more slowly. So it is a shallow region. As it passes into the slow region, what happens to the frequency? Well, frequency remains the same because source is not changing. And what happens to the wavelength of the wave? Well, speed and wavelength are directly proportional, so if speed is changing or decreasing, so would the wavelength. So it remains the same and wavelength decreases. Which is a unit of wavelength? Meters. We have done this question multiple times, and we have already done this question again. It has been shown to us. Option C is correct. Now this is the end of the worksheet. These were some challenging MCQs, and I've tried my best to explain them in a shorter amount of time. If you don't understand any explanation, if you don't understand an MCQs, and then if you don't understand the concept, you can basically tell me in the comments. I would explain it to you with my full knowledge and potential and time. Now till then, take care and goodbye, and thank you very much for subscribing to Atoms to Infinity. I hope it was worth of your time. Take care, goodbye.